we are starting our last unit for the semester. And we are going to be talking about parabolas and quadratic equations and functions in Unit 5. So we're going to start today by talking about the vertex and the standard form of parabolas. Now remember, parabolas are a U-shaped curve. Parabolas are a U-shaped curve. You're fine.
Is this whenever you said last unit you were like talking about parabolas and we were like, please don't talk about that. And
Oh, yeah.
I'll talk about it later.
This is later.
Oh, crap.
Yep, U-shaped curve. And they are always with quadratics, which means that we have an x squared in our equation. Before we start talking about parabolas, we're going to do a quick review over solving quadratic equations in a couple different ways. So we're going to start by solving by factoring. So what that means is that we factor the equation and then we set the factors equal to 0. So if I'm looking at number 1 and I want to factor this, what would my two factors be?
3 and 4. But it's going to be negative 4 plus 3.
Negative 4, positive 3. And so then I set them equal to 0. So x equals 4. And x equals negative 3, like that. Good. Now, the other one, I forgot to say, do you guys have your calculators today? If so, get them out.
Oh my gosh,
Now we have our calculators, and so let's use our calculator to graph the second one. So, well, not the second one, the same one. So remember, to find our x values, or remember, that's zeros is the same thing. So zeros and solving, same thing. I would go to y equals in my calculator, so everyone go to y equals in their calculator. If there's anything in there, clear it out.
How do you reset it again?
Second plus 712. And so if I am going to put this in, I go to y equals and I type x squared minus x minus 12. And then you can click on the graph and you can see the parabola. With this one, you can actually see where it crosses, where the zeros are at. And so you can actually count. But how do I do it if I can't see exactly where it crosses? Second trace, and then I click what?
The 0 button.
The 0 button, which is option 2.
Yeah, that one.
Second trace 2. And then remember, I scroll with left and right arrows. So I scroll a little bit to the left, enter, a little bit to the right, second plus 712. Enter, and then you click enter one more time.
You can see the
first equation, like the original, like x squared.
X squared minus
Don't
x
forget to write it in your
minus 12.
thingy-majiggies.
Right, and so this says now, it says 0, x equals negative 3, y equals 0. So we would write this as negative 3, 0. And then we would do it again. So we would do second trace 2. Use our right scroll to scroll a little bit to the left, which in this case is below. Click enter, a little bit to the right, enter, and then enter one more time. And it says the 0 is 4 and 0, so 4, comma 0.
Wait, one? Or
So what is a 0? It's an x-intercept.
wait, I'm confused.
So how do the zeros of the parabola compare to the solutions from number 1? Like, how do these two answers compare?
They're the same.
They are the same. They are the same. And so what this means is when we solve, we are finding what? The x-intercepts. So when we solve for x, like we did in number 1, we're finding the x-intercepts. When we're finding the zeros, we're finding the x-intercepts. Basically, anytime we're solving a quadratic function for x, we're finding the x-intercepts. So this even goes to show that solving an equation means finding the zeros, x-intercepts, or roots. All three of these words mean the same thing. They are all synonyms of each other, and they will be used interchangeably. Don't ask me to say synonym anymore, because I'll accidentally say cinnamon.
English word.
So we'll continue on. So it says, without using a calculator, find the x-intercepts of the following parabolas. So now we know when we're solving, we're finding the x-intercepts. So we can just continue to solve like we were doing in Unit 1 to find the x, or not in Unit 1, in Unit 4. So when we're solving, though, it doesn't tell me how to solve. So I could solve by factoring. I can solve by completing the square. I can solve by quadratic formula. Factoring is the easiest, so we always want to try to factor first. So for A, we're going to have y equals, or we can have, so an x-intercept is when y equals 0, right? Would you agree? What do you think? Yeah? Okay. So we can say 0 equals, and then we can factor x squared plus 7x minus 8. So what would that factor to? X plus 8, x minus 1. So do you see how this is making it set up to be an x-intercept? We're solving for x where y is 0. And so then we keep going. So x plus 8 equals 0. X equals negative 8. X minus 1 equals 0. X equals 1. Now, when it's asking for the x-intercepts, I want you to write them as points because they are points. So negative 8, 0, and 1, 0. And that middle thing is my and sign. It's not a plus sign. Okay, what about the next one? Can I factor it? Oh, let's see. 0. Oh, let me, hang on. Oh, no. What is happening? Give me a minute. I wanted to switch to red. So 0 equals, I've got 2 factors. So what would my x's be if it's 15x squared? 5x and 3x is a good place to start. Okay, and then for 30, what would my numbers be?
6 and 5.
Okay, 6 and 5. So remember, I can't do the 5 with the 5, so it would have to go like this, right?
Yes.
So then does that get me there? So I have 5 and 5 is 25, 6 and 13 is 18. Does that get me to 41? 25 and 18?
No.
No. And I can't switch them because of greatest common factors. So what's next? I guess what's next is 10 and 3, but I can't put them there because of common factors. So 3 and 10. So I'd have 10 and 5, which is 50, and 3 and 3, which is 9. Will that get me to 41?
Negative 3, positive 10. No.
Switch. Negative 10, positive 3. Good. It's okay. You got it.
I was there.
You were there. All right. So then we set each factor equal to 0. X, 5x plus 3 equals 0. X equals negative 3 over 5. And then 3x minus 10 equals 0. X equals 10 over 3. Once again, it's asking for x-intercepts, so we're going to write them as points. Negative 3 over 5, 0. And 10 over 3, 0. Now we're going to continue, but now we are finding the roots. Roots, x-intercepts,
Synonyms.
zeros, synonyms.
Oh, that was that.
Synonyms. Synonyms. All the same thing, okay? So we're still doing the same thing. So we're still going to try to solve by factoring first because that's the easiest. So if I have 0 equals, and then let's see, for 24, I could do what the closest ones together would be, what, 6x and 4x? And then for 1, wouldn't it just have to be 1 and 1? Yeah. And then it's plus, so it'd be plus. Does that get me to 10? Oh, I think it does, doesn't it? Yeah. So I have 6x plus 1 equals 0. X equals -1/6. Are you guys comfortable with me going from that to that
Yeah.
without showing any work?
Yes, ma'am.
Yeah? Okay. And then 4x plus 1 equals 0. So x equals -1/4. And then roots are x-intercepts, so we're going to write them as points. Ta-da! Okay, so let's try to factor again with this one. So y equals 2x, x. What would these have to be? They would have to be 1 and 2, right? Does that work?
No.
What about if you change the signs? Yeah, that's 4x and 1.
Would they just both be negative? That would be. Actually, that's a lie.
No, they can't both be a negative. Yeah.
That's a lie.
So, moral of the story, these don't factor. These don't factor. If they don't factor,
No solution.
no,
It's a straight line.
no. If they don't factor, I can't use factoring. So, doesn't, nope, doesn't factor. So if it doesn't factor, we have to use one of the other options. Would you rather use completing the square or quadratic formula?
No. Yes.
Completing the square, right?
Actually,
Completing the square.
I personally also like quadratic formula. And don't worry, we're going to do some more practice with completing the square today. So let's do quadratic formula. So I have A equals 2, B equals -1, C equals -2. And then
Bro does not like that.
da-na-na-na-na.
Bro does not like that. No, I think my worst grade and class and subject. Don't forget your plus minus.
Yes. Okay, how do I fill in? What do I use?
You use the A, B, and C. So you
Yep. Babaka.
A, B, and C.
A, B, and C as babaka, obviously. So double negative becomes positive. And then 1. Okay, negative, focus. -2, -4 times 2 is -8, right? And then -8 times -2 is -16/4. So that would be 1 plus minus square root of, no, wait. Oh, it'd be positive 16, because that's why I'm like, it's supposed to be 17. What's happening? Okay, there, like that. Now, there's quadratic formula, but once again, these are roots. They are x-intercepts. So we can write our answer as 1 plus square root of 17/4, comma 0, and 1 minus square root of 17/4, comma 0. So we can write them as points using the positive and the negative. So today we're going to talk about graphing parabolas. First, we're going to talk about vertex form, and then we're going to talk about standard form. Okay, so vertex form of a parabola is this equation here. Y equals A parentheses x minus h squared plus k. For this, A, H, and K are all going to be numbers. X and Y stay. Okay? So H, or A, H, and K are all numbers, and they signify different things that are happening on the parabola. Those different things will be, they will be shifting right or left, shifting up or down, making it narrow or more wide, stuff like that, okay?
That's A, H, and K or
A, H, and K are numbers. Yes. So with the vertex form of the parabola, the vertex form actually tells us a lot about the parabola. First, if I use H and K as a coordinate point, H comma K, that is my vertex. And we'll kind of talk about what all these mean once we draw it. But then also, h, if I do x equals h as an equation, like as a line, x equals h, that is my axis of symmetry, which we will also call AOS. So think about a parabola. Can you picture the shape of a parabola in your head? Yeah, it's a U, right? The vertex is the very bottom, okay? So we're going to start with the parent function. The parent function is the OG, like the original gangster, okay? It is the OG. It's the one we'll always go back to.
Wait, does OG stand for original gangster?
Yeah.
Yes.
I thought it stood for original.
Original gangster.
I thought it was like original.
No,
Old grandpa.
original gangster.
What?
Yeah.
Old grandpa. No, it's not a joke.
Yeah. So
No.
the parent function is y equals x squared. The vertex is going to be at 0, 0. So that's my first point. My axis of symmetry is always going to go through my vertex. I usually use a highlighter or a different color to show the axis of symmetry. You don't have to. You can just do a dashed line or something like that. But then this is my axis of symmetry. This is my vertex. Okay. Now we need more points than this though, right? That's not going to be very helpful. So in order to find the rest of our points for our parent function, y equals x squared, we are going to make a table. And we're going to have 5 points. So 1, 2, no, we're going to have 6 points. Wait, 5 points. 1, 2, 3, 4, like that. Okay. For setting up these tables, because I'm going to do several of them today, the middle of our table is always reserved for our vertex. The middle of our table. So in this case, 0, 0 goes in the middle. So there's 2 points above it and there's 2 points below it.
Oh my god.
Okay. So what we're going to do when we're setting up our table to find our points is we're going to go 2 points to the left and 2 points to the right of our vertex. My vertex is at 0, 0. So a point to the left would be -1. 2 points to the left would be -2. A point to the right would be 1. A point to the right would be 2.
So is it?
How I find my y values is I plug in to my function. So my function is just y equals x squared. So I'm going to plug in -2. So -2 squared is what?
4.
4. -1 squared is what?
1.
1 squared is, and 2 squared is. Those numbers always repeat. So you're always going to have whatever those numbers are. If it's 4, 1, it'll be 1, 4 on the other side. They match. Like, so these two will always match, and these two will always match because you're squaring.
Wait, are we?
So if we graph the rest of these points, so I've got -2, 4, -1, 1, 0, 0 from my vertex, 1, 1, 2, 4. And then I've got a parabola. I'm not good at drawing parabolas unless they're upside down. I don't know why, so I always turn my thing upside down to draw my parabolas. So this is our parent function for quadratic functions. This is the original parabola, so I guess it would actually be the OP, not the OG, original parabola. And this is the one we will go back to. This is the one that we base all of our transformations on. So you might be asking, how do I know when I transform something? Well, I'm so glad you asked. We're going to talk about that next. So each letter in our vertex form has a purpose for a transformation, except for x and y. X and y will always be there, okay? They don't mean anything. They just mean x and y. They just mean it's a function, okay? So we're going to start with A. A is the first thing that you see after the equal sign, okay? If A is positive, the parabola opens up. If A is positive, the parabola opens up.
No, I remember doing this.
Yeah. And so how I remember this is that positive people
Aw.
smile.
Oh, I thought you were gonna say open up.
Positive people smile. No, but look, my smiley face looks like an open up parabola.
Like open up to you. Like,
Yeah.
Nice, positive people will open up to you.
That's fine too. That's great.
I know
If-
some mean people will open
If
up to
A is negative,
me. Like, what?
then the parabola opens down.
Negative people frown.
Oh, Negative people
Are
frown.
you kidding me right
I
now?
get it, because the frown goes downward.
Yep.
And because frown rhymes with down, it's a
It
double
does.
meaning.
Whoa.
Yep.
Positive people smile doesn't rhyme, though.
It's okay. But positive people do smile.
Negative
Okay.
people frown.
Now, so that's the sign of A. If the sign of A is positive, then it opens up. If the sign of A is negative, then it opens down. If the number A is higher than, like the higher that it is, the bigger that it is, the more narrow the parabola is. Meaning the smaller that it is, the wider it is. So we'll kind of look at what those look like with different options, okay?
Wait.
So the next thing is H. H is inside the parentheses. If there's no parentheses and it's just x squared, then there's no H, or H is 0, okay? H is inside the parentheses and it tells us whether we go left or right. You might notice in the formula here, it's minus H. What that does is that changes our perception of what we're actually doing. So when H is positive, we are going to shift to the left. When H is negative, we're going to shift to the right. So it's opposite of what you would normally think of. Normally we think of right as positive and left as negative. But since there's a negative in our formula, it changes that. And then lastly is K. K is after the squared. Okay, it's after the square. And since it's a plus K, it's going to be normal from what we normally think. If it's positive, we're going to shift up. If it's negative, we're going to shift down.
Wait, what is that?
So in this section, so in each section that follows, we're going to talk about the differences. And I'm going to show you 2 different ways that you can use to graph your parabolas. Okay. I like to do it with tables because I think it gives a better understanding of what's actually going on. But then I'm going to show you kind of a shortcut, just more of a quicker way to graph your parabolas accurately with less effort. Okay, so I'm going to show you both ways because I want you to get the basis of what it means, and then I will show you how to do it faster. Okay, in this first section, we're just going to talk about the difference between positive and negative A's, and then what a number greater than 1 looks like for A. So first we're going to graph our parent function. So this is our parent. This is our parent. This is the OG. His vertex is at 0, 0. Okay? So we're going to graph it. Now at this point in my math life, I have memorized the points for the parent function.
What's
Okay?
a parent? Oh.
Parent is the OG, OP, original parent, original parabola. So I know that for the parent function of a parabola, it's -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. That's always going to be the same. And a lot of times we will start with the parent function and then we will shift based off that. So you'll get used to making the parent function a lot, which will make you remember it easier.
Wait,
Okay.
where are you saying?
So now we're going to talk about, now that we have our parent, we are going to talk about y equals 2x squared versus 1x squared. So 2x squared, there's nothing going on, there's no parentheses, so there's no h, there's no k. So that means my vertex is still at 0, 0, like this, okay? But since A is a higher value than 1, okay? So normal is 1, 1x squared. This is 2x squared, so it's more.
It's gonna be narrow.
That's going to mean, right, it's going to be more narrow.
Can we name this one child?
Sure. And so we can make a little table over here. And since we didn't shift our vertex any, we can use the same original points. So -2, -1, 0, 1, 2. So I'm recreating the table that I created for the parent function at the beginning.
Are the Y's the same still?
No, they are not. Because instead of it being y equals x squared, it's y equals 2x squared. So this is where the more complicated these get, the better it would be to have a calculator. With this, I think we can do it on our own. So -2 squared is 4, right? But then we have this 2 here. So 4 times 2 is 8. So this is going to be 8 now. -1 squared is 1. 1 times 2 is 2. 0 squared is 0. 0 times 2 is
Wait, why are you
0. We're making new points for this function. And then they repeat. So once I have 8 to 0, I can just do 2, 8. They will always repeat. Okay?
You multiply by whatever is in front of
Yep. So you square first, then multiply just like you would normally. Okay?
PEMDAS.
PEMDAS. Now, 8, oh, sorry. -2, 8 is too big for this graph, so we're just going to do -1, 2, and +1, 2 with our vertex. And we've got our new parabola, which you can see is more narrow than the original one. Now, the next one is -2x squared. So that means this one is going to open down, and it's also going to be more narrow. The vertex doesn't change because we didn't shift left or right. So the vertex is still at 0,
Hold up.
0.
How would you know if it's just left or right?
You'll see. We haven't gotten there yet.
Why did we not graph -2, 8? Is it just because
It's too
not all
big,
the way?
yeah.
Okay. So we won't get in trouble if it's not on.
Wait, this one's
Right.
going downward.
It is. Now look, let's see what this looks like with the points though. So we didn't shift left, right, up, down, or anything, so we can use the same numbers. So -2, -1, 0, 1, 2. But this time when we plug in, we're gonna get something different. So -2 squared is 4. 4 times -2 is -8.
So is it just gonna be all those points over there with negative?
Yep, -2, 0, -2, -8. We still can't graph the 8s, but we can graph the other ones. So now I'm going to have -1, 2, and 1, 2. And so it opens down. So let's talk about the shortcut, I would say. So this is the traditional way of graphing parabolas, where you make tables, you find points, you graph them. No, we're not moving on yet. We're not moving on yet. We're not moving on yet. Okay? We're staying on this page. Okay? I'm going to introduce you to something that Miss Leininger taught me, and I have now officially termed it as a real phrase.
Beautiful.
It is called quote
Guys,
slope. And it is called quote slope because slope is in quotes. Okay? Quote slope. Yep. So quote slope is basically using A as our slope. Okay? Using A as our slope. That's what quote slope is. Okay? And so when I was talking with Miss Leininger about pre-calc and what they use this for, she said that she just requires you guys to know the first 3 points. So you just need to know basically here, here, here. Does that make sense?
Good.
Okay?
I like this.
And so with that being said, if you only need those 3 points, you can use quote slope. Now here's the deal with quote slope though. Quote slope has some parameters. Quote slope is only for points, only for, let's rewrite this actually, only for 1 point to the left and right. You'll see. Only for 1 point to the left and right. So we've got our vertex in the middle, right? Quote slope only works 1 to the left, 1 to the right of the vertex. That's it. Okay? It does not work any further. Any further points that you want out from the vertex, you have to use a table. Quote slope, you go from your vertex, you go one left, one right, okay? Which is all that I'm going to require of you. So let's talk about what this looks like. So let's look at the parent function. For the parent function, my quote slope is going to be 1 because the number in front of x is 1. So that's normally what slope is, right? So I'm going to make it 1 over 1 so that it's my rise over my run. Okay? So from my vertex, I'm going up 1, right 1, but I'm also going up 1, left 1. That's what kind of makes it quote slope because it's not real slope because we're going to go left and right, but only 1. Okay? Just give it a minute. I don't love it here, but once we get to more complicated things, I really like it. Okay? Trust. Okay? Okay? So then here, with B, my quote slope is 2 over 1 because my value in front of x is 2. So from the vertex, I don't go up 1 over 1. I go up 2, right and left 1. That gets me my first 3 points. Okay? Are you following?
Oh, no.
With C, my quote slope is -2 over 1. So from my vertex, I go down 2 and then right and left 1. So here, we're going to do all 3 of these with the tables, and then we're going to go back and do them with quote slope so that we can see both, okay? For these ones, we're talking about when A is a fraction or when A is less than 1, okay? When A is less than 1. So all the other ones were when A is greater than 1. This one's going to be when A is less than 1. D is the parent. So this is the OP. So we're going to graph it again. So like I said, we'll get used to graphing the parent function. So using the same points as we did from that very first one, which are 0, 0, -1, 1, -2, 4, 1, 1, 2, 4.
Why is that the parent?
Because it's the original. Nothing has changed from it. It's y equals x squared. And the reason why the parent is at the beginning of each of these sections is so we can see, okay, here's the original. Now here's how it changed. Yeah? Just to visualize it. So with this next one, for E, my A value is not 2. It is 1 over 2. Okay? So think about it this way. If my A value is larger, that means my graph is getting more narrow. If my A value is smaller than 1, it gets good. It gets wider. So let's see what that looks like. So we're going to have, so we did not shift left or right, up or down, so our vertex is still going to be at 0, 0. Don't worry, we will get there. So I have X, Y, like this. You did it? Already? Okay, good. So I picked the same X points, -2, -1, 0, 1, 2.
You should divide it by 2.
Yep, so we would do -2 squared, which is 4. 1/2 times 4 is 2. And then -1 squared is 1. 1/2 times 1 is 1/2. I'm going to make it 0.5. And then they repeat.
I was just making it.
You'll see. Okay? So there are my points. So I'm going to go -2, 2. -1, 0.5 or 1/2. So just halfway up. 1/2, 2, 2. And then we graph it. And it is wider than it was before. Do you think the next one is going to be more or less wide than the last one?
Wait, let me think about it. Wider. Narrower.
What do you think?
No, it's going to be narrower than the last one.
Oh,
Because,
no, it's going to be
because it's closer to 1.
narrower.
Okay, it's closer to 1.
Which means it will be
So,
narrower than the last.
Isn't it 4?
I'm just going to put less wide, but still wide.
Yeah.
Like still wider than the original, the OP, but narrower than the last one. What does this negative tell me?
It's gonna go downward.
Opens down.
Frown.
Okay.
Frown. Wait.
So let's talk about these points. So I've got x, y, -2, -1, 0, 1, 2. -2 squared is 4. 4 times -3/4, are we listening? Is -3. So this is something we could do. So -3/4 times 4/1. The 4's cancel. -3. Yeah. For -1, it'll be -0.75, 0, 0, -0.75, -3. So then when I graph it, I have -2, -3, -1, -0.75. So like they're not.
This is like above my pay grade. Why are we doing
Above your pay grade?
Welcome to life.
I don't understand how to graph 0.75.
Your whole life is going to be above your pay grade, promise. Now that we have all 3 of these graphed, I'm going to explain, are we listening?
Yeah.
I'm going to explain quote slope. This is the last time I'm going to explain it, and then we're going to start using it, okay? Cool? So, quote slope here is different, not different, it's the same concept, it just, you have to treat it a little differently. So, for quote slope, we've been using the number in front of x, but this time it's a fraction. So normally we were putting it over 1, right? 2/1, 4/1, whatever. Quote slope only works 1 to the left and 1 to the right. Okay, are you following?
No.
It only works from the vertex, 1 to the left, 1 to the right. If 1/2 was my slope, I would go up 1, right and left 2. Would you agree?
Yeah.
Like rise over run. Think
Yes,
about rise over
yes,
1. You would go up 1, right 2, right?
That's what I did.
But, quote slope only works 1 to the left, 1 to the right. It does not work 2 to the left and right.
So what do we do?
So what do? What we do is something a little different. We're going to do 1/2 over 1. Or somebody yesterday was like, can I just do 0.5 over 1? Yes. So that's my rise over my run. So that means I go from my vertex, I go up 1/2, right and left 1, which still gets me those bottom 3 points.
This is so confusing.
It's just a little different with the fractions.
Is the next one
Okay.
0.75 over 1?
Yep. Well, so
Negative.
negative. Good. So my quote slope
The quote slope?
is -3/4 over 1 or -0.75 over 1. So from 0, we go down 0.75, right and left 1. On the next section, we're going to talk about shifting right, left, up, down.
So
Okay? Actually, just right and left.
So H? Or
So H. So here we're talking about H. Here we're talking about H. Okay? Now, in G, we have y equals parentheses x plus 2. X plus 2. So that means, remember, it's opposite of what I would normally think. So since it's plus 2, that means I'm going left 2. Would you agree?
Yeah.
Okay. Is there a number in front of x or in front of the parentheses?
No.
No. So this is still, it's 1. So this is still the parent function, but it's just the parent function shifted left 2. So what that means is instead of my vertex being at 0, 0,
Oh.
my vertex is at -2, 0. Left 2, right here. But from here, I do the same pattern as I did for parent function.
I get it.
Yeah, so I go over 1, up 1, and then up to 4, up to 1, up to 4. And I graph. Once again, quote slope would work here. You just do up 1 over 1, up 1 over 1. Okay? But with parent function, I just went ahead and added the top points as well. You don't have to, but I just do for parent. Okay? Does that make sense, though, going left 2? Yeah? For the next one, I have a -1 in parentheses. So what does that mean? It's going right 1. And then I have this 2 here. That's my A value. Or we could say our quote slope is 2 over 1. Okay, so you ready to use quote slope? So we're going to go right 1. Here's our vertex. So our vertex is now at 1, 0. And then from our vertex, we're going to use quote slope. So from our vertex, we're going to go up 2, right and left 1. And there are our points.
So H is our
Done.
vertex.
Yes.
Okay, wait, so
So for the next one, I have a plus 1. So that means I'm going left 1. So my vertex is at -1, 0. And then I have a -2. So that means my quote slope is -2 over 1. So from my vertex, I go down 2, right and left 1.
So the point of that -2 is literally just like the slope.
Yes.
That's it.
The quote slope, yes. We are going to be using H and K and A. All the things, okay? All the different things happening. So for J, is there a number in front of my X?
No.
There's a 1, right? So that means this is the parent. So OP, original parent, original parabola.
Every time it's a 1, is it an OP?
Yep, it's an OP. Okay, and then I've got a -2. So what's that going to be?
Right 2.
Right 2. And then back here behind the square, I have a +1. So what's that going to be?
Shift 1.
Which way?
Up.
Up 1. Okay, so that means from where my vertex is normally 0, 0, I'm going to go right 2, up 1. So that means my vertex is at 2, 1. Okay. From here, my quote slope is 1 over 1. So I'm going to go up 1, right and left 1, and graph. So, good. So my A value is 1/3. So that means my quote slope is 0.75. No, 0.25. 0.25. No, that's wrong because it's a third, not a fourth. Yeah, so I'm just going to leave it as 1/3 over 1. I don't want to do like 0.67, whatever. Yeah. Yeah. It's okay. I was on the same wavelength. It's +1, so that means I'm going to go left 1, and then it's -2, so that means I'm going to go down 2. So from 0, 0, I go left 1, down 2. So here is my vertex.
Would it be incorrect to think of the +1 as just the vertex?
No, because it's not just the vertex. So when you have both, they're both the vertex.
I'm sorry.
Because we go left and down. So that means the vertex here is -1, -2. Okay? Yeah? Now, our quote slope is 1/3 over 1. So that means I'm going to go up 1/3, right and left 1. So just barely up. And what that means is that it's a lot wider like this.
What's
This very last one, we've got the number in front of X is -2. So my quote slope is -2 over 1. Now, there's nothing in parentheses here. So am I shifting right or left?
No.
No shift right or left. But there's a +3 after the square. So am I shifting up 3? And that's it. Okay, that's all I'm doing, just shifting up 3. So that means from 0, 0, I'm shifting up 3. So my vertex is at 3, 0. And then I use my quote slope to go down 2, right and left 1.
Could you, like, really just for a second show me?
So now we're going to do standard form, where standard form is our standard form of our parabola or our quadratic equation, I mean. And so it's y equals ax squared plus bx plus c. So that's what you're presented with. You're not presented with something that is in vertex form with the parentheses and the squares and the A, H, and K. This one, you're presented with something like this, where it's y equals 2x squared plus 4x minus 1, okay? And so in part C, I guess is what it's called, in the last part of the lesson, we are going to talk about how to go from standard form to vertex form. But right now, we're just going to talk about how to use standard form to get all of our essential pieces that we need, okay? So first, we're going to talk about, first we need A, B, and C for our equation. So we need A, B, and C. So what is my A for this equation? 2. What's my B?
4.
And what's my C? -1. Okay, so the first thing it asks for is the axis of symmetry. And so normally the axis of symmetry goes straight through the vertex, right? We talked about that. And so we kind of used the vertex to see where the axis of symmetry was. Now we're going kind of out of order. So in order to find the axis of symmetry, there's actually a formula for it. It's x equals -b over 2a. So this is a new formula you will need to memorize. And what's really hard is that this formula is very similar to the b over 2 squared from completing the square. So you have to kind of keep those separate in your mind, okay? So if I do -b over 2a, that's -4 over 2 times 2, which is -4 over 4, which is -1. So the axis of symmetry is x equals -1. Okay? Using that new formula. So x equals -1. So if I go over 1 right here, here is my axis of symmetry. Actually, I might put that down at the bottom. Okay? So that's how I find my axis of symmetry when my equation's in standard form. To find my vertex is always on my axis of symmetry, right? Would you agree? Like the very bottom of the parabola on the axis of symmetry? Yeah, it's going to be somewhere on this dashed line. I just don't know where, okay? So meaning I know where the x value is, but I don't know where the y value is. I don't know how high or how low it is. Does that make sense? Okay, so I take my x value. So the axis of symmetry is x equals -1. So I forgot I did add little notes to these at the bottom. So the axis of symmetry is always going to be x equals a number. And with the axis of symmetry, it is a line. And so you always have to put x equals -1. If you just put -1, I will take points off, okay? It needs to be x equals. So
Did it like you do at the top, would it be fine?
yes. Yep, x equals -1. For the vertex, we are going to plug the axis of symmetry into x to find y. So what that means is into our x for our equation. So we have an equation up here, y equals 2x squared plus 4x minus 1. So we're going to do y equals 2 times -1 squared plus 4 times -1 minus 1. So we basically plug x in. When we plug x in, we should get -3 when we evaluate that. It's okay if you didn't do that as fast. I have the answer key, don't forget. But you should get -3. So that means my vertex is at -1, -3. 1, 2, 3. So here's my vertex. Okay. It asks for the y-intercept. The y-intercept is always going to be found by doing 0, C. So the point is 0, comma, C. C is that very last value. So C is -1 here. So that means my y-intercept is at 0, -1. So 0, -1. So here's my y-intercept right here. And then I can reflect my y-intercept over my axis of symmetry to find the third point. So if my y-intercept is at 0, -1, it takes me one step to get to the axis of symmetry, so I can do one step on the other side, and now I have 3 points. You can also still use quote slope. Yeah. So whatever that very last number is in standard form is our y-intercept. So if I was to use quote slope here, it would be my a value, which is 2. So my quote slope would be 2 over 1, which still works because I would go up 2, right and left 1. Yeah.
Okay, so
All right. So with the next one, it's f of x. Remember, f of x is the same as y equals, right? Like they're the same thing. So it's y equals x squared minus 6x plus 3. What is a? What is a? 1. What is b?
-6.
And what is c? 3. Okay, so does this graph open up or down? Up, why?
Because it's a positive.
It opens up, and it opens up because a is positive. A is positive, okay? So then it wants us to find the axis of symmetry. So we're going to do x equals -b over 2a. So we have -6 over 2 times 1. So that's 6 over 2, so 3. So my axis of symmetry is x equals 3. 1, 2, 3. Da-na-na-na-na-na-na-na. Axis of symmetry. Now to find the vertex, I'm going to plug the axis of symmetry into the equation. So basically I'm doing f of 3 equals 3 squared minus 6 times 3 plus 3. Are we doing what? Corrections on the quiz? After break. Okay. So 3 squared minus 6 times 3 plus 3 will end up giving you -6. So my vertex is at 3, -6. So 1, 2, 3, 4, 5, 6. So here's my vertex. And then to find the y-intercept, it's always going to be 0, comma, c. So it is 0, comma, 3. So that means I go on the y-axis up to 3. 1, 2, 3. Plot the point. And then I can reflect. So 1, 2, 3 steps. 1, 2, 3 steps. Plot the point. So you can still, like I said, you can still use quote slope, but you can also use this when it's in standard form, which I think is pretty easy. What if it's not what? Then we would use vertex form. It'll either be in standard form or vertex form. So last part of this lesson is changing from standard form to vertex form. We can do this by doing our favorite thing, completing the square.
You didn't put it in the shadow.
So what we're going to do is we're going to complete the square with our equation. Now, you guys need to lock in for this because it's going to be weird, okay? So you need to pay attention. Are we ready? All right, so for completing the square, our first step is always to move the constant to the other side. Okay, normally with completing the square, we have 0 equals because we're solving. But this time, we're not solving for anything. We're just rearranging our equation so that it's in vertex form, okay? Going from standard form to vertex form. So this y is going to stay, okay? So we're going to have y minus 2 equals x squared minus 2x plus blank, and then we have a plus blank over here. Okay, so normally we would have like -2 equals because it would be equal to 0 and we would subtract 2 from it. But since we're just rearranging the problem, that y is going to stay there, okay? So then at this point, to complete the square, this is when we do b over 2 squared. B over 2 squared? Yeah. So what is my b value here? -2. So I do -2 over 2 squared, which is -1 squared, which is 1. So I add 1, I add 1.
Can you clarify which -2 it is?
Yes. Boop, 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 boop. Now, the reason why I do all of my steps here, okay, because yes, technically I don't need to, right? I know that -2 over 2 is -1 and -1 squared is 1. I don't need to do all that. But this value here, the value that I get before I square, so the value that is being squared, is always going to be my number when I factor this. So it's always going to be whatever that is, just comes down here, so that it's x minus 1 squared. That's also why I always bring the sign with me when I do b over 2 squared, because yes, it's squared, so it's always going to be positive, but whatever that sign is before I square it, that's the sign that I get in my factor. So that's how I know it's x minus 1, not x plus 1. Okay, you also can just factor it like normal, like with trial and error, but this is just a shortcut, okay? And then on the left side, I'm going to combine my like terms. So I have 1 minus 2, so I'm going to have y minus 1, like that, okay? And then I'm still trying to get y by itself, so I'm going to add 1 to both sides, so that now I have y equals x minus 1 squared plus 1. And so now it is in vertex form. Factored form looks like y, oh my gosh.
Because when I think of like the square, I think of the like x plus 5 times x minus 5.
Yeah. Yeah, difference of squares, yeah. So with vertex form, which is what I'm trying to get here, that's y equals a parentheses x minus h squared plus k. So we're trying to get it from standard form, which is y equals a x squared plus bx plus c, to vertex form. So that's why, like, when we're doing all of this, we're doing completing the square because now I have this thing that looks like this.
Yeah.
Does that make sense?
Okay.
So now that I'm here, I can graph this. So if it's x minus 1, does that mean I'm going right or left 1?
Right.
I'm going right 1. And am I going up or down? Up 1. And then what's my quote slope? 1 over 1. So I'm going to go right 1, up 1. And then my quote slope is up 1 over 1, up 1 over 1. Okay, the next one is going to be significantly more complicated because why do you think? Because there's a 2 in front of the x. Now, let's talk about completing the square because I'm not going to lie, I didn't teach you wrong. I taught you the way that I like to do completing the square. And if you watched like Miss Napier's video or looked at any of the other resources, you might be able to like catch on to this easier. But remember when I taught you completing the square, we would just divide everything by 2 to get rid of it so that it was 1, yeah? Here, we can't necessarily divide by 2 because that 2 is important. That 2 is my a value, right? So that's what tells me if I get wider or more narrow. So I can't just divide and get rid of it. So I have to do something I'm doing the same thing. I just have to keep it in the picture. I can't just get rid of it like I did with completing the square, okay, originally. Because I need to have that y equals a parentheses. It's not there. X minus h squared plus k. I need this a value, which is this 2. So I can't get rid of it. So we're going to do something a little different. But like I said, it's still a very solid way of completing the square. Okay, so we're still going to move the 16. So we're going to move it, so that we have y minus 16 equals, like that. Now, instead of dividing everything by 2, we're going to factor the 2 out, okay? Everything's divisible by 2. So we're going to factor the 2 out, okay? So that it's still there. It's still giving me an x squared, right? But I didn't lose the 2. So I have x squared minus 6x, and then this is where my plus blank goes. And then my plus blank over here. Okay. So yes, now at this point, I would do b over 2 squared. So let me come over here and do that. So I'd have b over 2 squared. Here is my b value. So negative 6 over 2 squared, which is negative 3 squared, which is 9. So I add a 9 here. Okay. Now, normally, add a 9 to one side, add a 9 to the other side, right? But there's this 2 that we didn't get rid of. Okay, so I really didn't add 9. I added 18. Okay, so now I'm going to factor the right side. So this 2 is still here. I have something squared. It comes from here. So it's x minus 3. Okay. So when I factor with trial and error, it'd be x minus 3 times x minus 3, so x minus 3 squared, yes? And then on the left side, we have y plus 2, 18 and 16 subtracted. Yeah?
I don't think you were too confident on that one.
I wasn't. I had to look at my key just to make sure. Okay, now I move the 2. And so I have y equals 2 parentheses, x minus 3 squared minus 2.
So that means that the axis of symmetry is 2. Wait, no.
So yes, so the vertex, or sorry, not the vertex. I mean, it is the vertex, but so we're going, right 3 down 2. And our quote slope is 2 over 1. Yeah? It's just a lot more difficult. And so we're going right 3, down 2. So here's our vertex. And then our quote slope is up 1 over 2. All right, so one more. So we are going to move the 12. So y plus 12 equals. We are going to factor out the negative 4. Yes, we have to bring the negative with it because we want x to be a positive 1. Or x squared to be a positive 1. So we have x squared. Negative 16 divided by negative 4 is positive 4x. And then I do my plus blank, plus blank. Now I do my b over 2 squared. So 4 over 2, 2 squared is 4. So I add a 4 on this side, but remember it's 4 times negative 4, so what do I add to the left? Nope, 4 times negative 4. 16, negative 16, okay? So then on the left side, I have y minus 4 equals, I have this negative 4 here, and I factor the perfect square trinomial to x plus what? What do y'all think? X plus 2. X plus 2. And then I add the 4. So y equals negative 4 x plus 2 squared plus 4. Okay, so tell me what I'm doing.
You go left 2, up 1, or up 4,
Mm-hmm.
and your thingy is negative 4 over 1.
Good. Okay, so left 2, up 1, 2, 3, 4. So right there.
And then you go down 4 over 1.
Good. Down 4, right and left 1. Okay, so the very last one has a fraction in it, which does make things a little complicated, okay? We're going to start off the same way. So we're going to move our 2. Let me zoom in here. Okay, so we're going to do plus 2, plus 2. So I have y plus 2 equals, we're going to factor out a 1/2. Okay, I factor it out of 1/2 so that I have x squared. Now, when I factor out, I'm dividing out, right? So like when I factored out the negative 4 in the last one, I divided negative 16 by negative 4 to get the positive 4. Yes? So I'm doing the same thing here. So I'm factoring out a 1/2. So I do 2 over 1 divided by 1 over 2. Okay? We always flip and multiply. So 2 over 1 times 2 over 1 is 4. So this is going to become a 4x. Okay? So now with this, I'm going to do my b over 2 squared with this number. So 4 over 2 squared, 2 squared, 4. So I add a 4, but I don't just add a 4. I actually add a 4 times 1/2. So now we're going the other way. We're not dividing anymore. 4 times 1/2 is 2. Okay? So then I have y plus 4 equals 1/2 x plus 2 from over here. And then I subtract 4. So I have y equals 1/2 x plus 2 squared minus 4. I know. Okay, so this means I'm going left or right 2? Left 2, up or down?
Down.
Okay, and then what's my quote slope? Trick question. Think about it before you answer.
2. 0.5.
Good, 0.5 over 1. It's 1/2 over 1. Remember, quote slope only works 1 to the left and 1 to the right, right? So I can't go up 1, right 2 with quote slope. I have to go up 1/2, right 1.
Which is still,
The same thing.
yeah.
But, well, it is, but it won't continue that pattern outside of 1 to the left, 1 to the right. Does that make sense? Like it does something different on the outside of that. So that's why you have to use just 1 to the left, 1 to the right. So I would go left 2, down 1, 2, 3, 4. And then I go up 1/2, right and left 1, like that. Because it's wider.
And y is 2, wait, is it? Oh, it is -2, and then. I'm so proud of us, we did it.
Yay.